Recording is in progress. Okay. Now, students, today we're going to work on similarities in area. Okay. This topic will involve a lot of triangles. You need to find the area of triangles. You need to see which triangles look the same as the other triangle, which triangles have the same area. Okay. So I'm going to show you the worksheet. The first thing that we need to learn today is the concept. Oh, where's my pen? Hold on, let me get my pen. Oh, where's the Apple pen? And I got it. Okay, students. So I'm sure we already know how to find the area of a triangle, don't we? Okay. In order to find the area of a triangle, we need to make sure that, okay, so let's say we have a triangle here. We need to make sure that we know what is the length of the base. And we also need to know what is the height of the triangle. And the height must always be 90 degrees to the base, okay? So this is the height. Now let me ask Abby. So Abby, if I were to tell you that the base of this triangle, okay, has a length of 10 centimeters, and if I were to say that the height is 5 centimeters, can you help me to find the area? What formula should I use?
Height times base
Abby?
divided by 2.
Do you know how to find the area of a triangle, Abby? Okay, can you tell me what should I use?
Height times base divided by 2.
Okay, hold on. Can't hear you, but let me just check my... I don't know why I cannot hear Abby. Hold on, You... Yes. Okay, Abby, how do I find the area of this triangle?
Height times base divided by 2.
Okay, height times base divided by 2. You are absolutely correct. So what we usually say is half times the base times the height. Now in this case, what are the numbers? Can you fill it in with all the numbers? Half times? What is the base?
10.
And what is the height?
5.
And the answer is?
25.
Well done. So now we know this. Okay, I'm going to draw another triangle. Okay, Abby? Let me draw another one. Now I'm going to draw a black one. Okay. Now I'm going to tell you that the base is 5 centimeters. And I'm going to tell you that the length over here, 90 degrees, is also 5 centimeters. So can I say that the area is half times 5 times 5?
No,
Why not?
because you have to do the base times the length next to the height you drew.
Okay, so are you telling me that whatever I drew here is not the correct height?
Correct.
Okay, so this is the wrong height. Are you telling me that this is the correct height?
Yes.
Now what did I say about the height? What is this? What is this here? What is this?
90 degrees.
Now, if this is the base, does this look like 90 degrees to you?
Yes.
Do you think this is 90 degrees?
No.
It is slanted, isn't it?
Correct.
So can I use this as the height?
No.
No, we cannot. Okay, we must make sure that the height is 90 degrees to the base. The correct height is this one. Okay, Abby? Got it?
Okay.
All right, well done. Now let me test someone else. Ben. Okay, Ben, I'm going to test you, okay? The base should always be how many degrees to the height, Ben? How many degrees? Look here. Do you know what is the meaning of 90 degree?
Yeah.
Okay, that is called, what kind of angle is that called?
Right angle.
A right angle. So the base must always form a right angle with the height. Okay, Ben? So I'm going to draw something for you now. Okay, so let's say I have this Then this is 90 degrees. Can I say that this is the base and this is the height? Yes or no?
Yes.
Very good. Now, if I were to draw a different triangle that looks like this. Oops. Okay, that's not even a triangle. Okay, this triangle. Can I say that this is the base and the height is over here 90 degrees? Yes or no?
Yes.
Can I say that this is the height 90 degrees?
No.
Okay, what is wrong here? The base is at the wrong place, the wrong position, right? The base should always form a 90 degrees with the height. So the base should be here. And then you have 90 degrees here. And then you have the height over there. So let's draw it properly. Okay, this is the base. If you want to find the height, you need to extend the line and you need to make sure that this is 90 degrees. Then you can say that this is the height. Okay, Ben? Okay, now let me draw another triangle. Okay. So, Ben, over here, this triangle is slanted. Okay, slanted. If I were to say that this is the base, okay, the height must always be how many degrees to the base?
90.
90 degrees. Very good. So let me draw some lines, okay? Okay, this is 90 degrees. This is, let's call this number 1. This is 90 degrees. Let's call this number 2. And let's say that, okay, let's say that I have another one. Let's call this number 3. This is 90 degrees. Which line do you think is the correct height? 1, 2, or 3? This is the base, huh? Okay, look here. This is the base.
2.
Number 2. Well done. The base must be 90 degrees to the height. If this is the base, then this is the height, 90 degrees. Okay? If this is the base, and you have this line over here, number 1, this line number 1 is not even 90 degrees to the base. This line number 3 is also not 90 degrees to the base, so it cannot be the correct height. So every single height must be 90 degrees to the base. Well done, Ben. Let me, okay, so now we already know how to find the base and the height. We must make sure that the height is always 90 degrees to the base. So let's look at this butterfly here. Okay, this is called the butterfly concept. Why do I call it the butterfly concept? There, this one, the butterfly concept. Because this looks like the wings of a butterfly. Simple. So, let me ask Junchen, okay? Junchen, if I were to, okay, let me just highlight the triangle first. This is the yellow triangle. And this would be a green triangle. Junchen, if you look at these two triangles, and we already know that AB, the line AB is parallel to the line CD. Okay, what does it mean if it is parallel? Do you know, Junchen?
Means the lines never meet.
The lines will never meet. So if I were to draw the height from here to here, and if I just draw the height from B to D, do you think this height will be the same as this height?
Yes.
Yes, because the lines are parallel. Okay, well done. You are correct. So, oops, did I just erase my yellow? Okay, done. So now I have a yellow triangle, I have a green triangle, and you have a set of parallel lines. The base of the yellow triangle is over here. What about the base of the green triangle? Is it the same?
Yes.
Yes, it is the same. Now, the height of the yellow triangle, the height must always be 90 degrees, correct?
Mm.
So if I were to draw the height of the yellow triangle, it will be 90 degrees. Oops. Okay, let me just shift it a little bit so that it's touching the tip of the triangle. So this is 90 degrees. Can I say that this is the height of the yellow triangle?
Yes.
Okay, the green triangle?
The same.
Yes, the same. They have the same base. Agree?
Yeah.
They have the same height. Agree?
Yes.
How to find the area? Area is half times the base times the height. If the triangles have the same base and the same height, do you think the area will be the same?
Yes.
Absolutely correct. If two triangles have the same base and the same height, okay, let's just try, okay? Let's call this 5 cm and let's just say that this is 10 cm. So let's find the yellow triangle. Half times, what is the base, Jinsen?
Base is 5 cm.
The height is?
Height is 10 cm.
And we get,
Yeah, square.
let's find the green triangle. Half times, what is the base?
5 times 10.
And we get the
35 cm square.
same answer. And therefore, the area is the same. Good.
Yeah.
Well done. Thank you, Junsen. So students, as you can see, when you have parallel lines, you already know that the height is the same, okay? If the height is the same and also the base is the same, then the area will be the same. So same base, same height will always give you the same area. Now, my next question, Kate. Do you notice that the yellow triangle and the green triangle overlap each other? Kate, are you there? Oh, I think she's not there, is it? Okay, never mind. I'll come back to her later. Maximus, the yellow and the green triangle are overlapping each other. Yes or no?
Yes.
Oh, hi, Kate. Hi, Kate. Do you hear me just now? Can you say something can you say hello?
Hello.
Okay, yeah. Anyway, I'll call you later, okay? I think you didn't hear me just now. Okay, so Maximus, they are overlapping each other. The yellow and the green triangles overlap each other. The overlapping part is actually over here, right?
Yes.
Let's call this, okay, this is P, this is Q, PQ, then let's just call this R, all right?
Sure.
Can I ask you, Maximus, how do I find the area of P?
Half times.
How can I find the area of P? You must take the yellow triangle minus minus
the P, the
minus minus R. Very good. How do I find the area of Q?
Use Q minus the R.
Q minus R. Q minus R.
No. Use
Then
the green triangle minus R.
green triangle minus the R. Very good.
Because green triangle.
So do you think that the area of P and the area of Q are going to be the same?
Yes.
Why? Because yellow and green are the
Same.
very good. Because the yellow and the green are the same, you are taking the same thing, minus away the R. You're taking the same area minus R. And R is always the same. You see, R is the same.
She take on my worksheet just now.
Thank you, Maximus. Okay, so you see, students, now we already know how to find the area of P and Q, and we realize that the area of P is the same as the area Q. That means this area and this area are the same, and therefore, whenever you see two overlapping triangles and you see them in parallel lines, you should use the butterfly concept The butterfly concept tells you that the butterfly wings, okay, the butterfly wings, area P, will be equal to the other butterfly wing, area Q. Any questions, students? Okay, let me repeat one more time. What does the butterfly concept tell you? Whenever you have parallel lines and you have two triangles overlapping each other, you must check, okay? Is the base the same? Do they have the same base? Yes, they have the same base. Do they have the same height? Yes, they have the same height. Is the overlapping area the same? Yes, the overlapping area R is the same. And if everything is the same, P will be the same area as Q. Now that you understand the butterfly concept, let us try a question that involves the butterfly concept. Everybody, can you go to page number 7? Page number 7, question 6. Can you look at the diagram here? Now, let me explain what the question is asking, okay? They tell you that you have two quadrilaterals. Okay, what is a quadrilateral? It just means four-sided shape, okay? They say that they are squares. That means ABCD is a square. EFG, DEFG is also a square. So you have two squares. And they also told you triangle CDH has an area of 8 cm square. What is the question trying to ask? Find the area of triangle AFH. There you go. They want you to find this area here. Okay, students? Can you try to use the butterfly concept to find the area of AFH and type your answer in the chat group? I'll give you 2 minutes. Try now. Let's Kate, you can hear me. That's good. Nicholas, let's try this together, shall we? So, Nicholas, let me ask you the first question. Do you see any butterflies here?
Yes.
Okay, where? In order to have a butterfly, do you need parallel lines?
Yes.
Yes, you need parallel line. Okay, you see here? You need a set of parallel lines, right? So where can I find the parallel lines? Is it from A to B and E to C? Is it A to B and E to C parallel lines? Should I use this? Nicholas? No. Does anybody know where I should have my parallel lines? Anyone? You can type it in the chat. Anybody? Type the alphabets. Type the alphabets if you know where are the parallel lines. Talia. Talia say H to D and B to C. Talia, unfortunately, H to D and B to C, they are parallel, but there are no triangles inside the parallel lines. Very good, Abby. Wait, Abby say A, B, and C, D. No, Abby. A, B, and C, D, yes, they are parallel, but where are the triangles? The triangles are not inside the parallel lines. So Maximus, well done, Maximus. Okay, Maximus says that you have to draw the parallel lines from A to C and F to D. You are correct, Maximus. So, Nicholas, now that I've drawn the parallel lines A to C and F to D, can you see that the butterfly wings are over here? Can you see the butterfly wings here, Nicholas? This is one butterfly wing, and this is another butterfly wing, right? So Nicholas, why do I say that these are the butterfly wings? If you look at the triangle, okay, let me erase the yellow and green first. Nicholas, I want you to look at this triangle. Can you tell me where is the base of the yellow triangle? What is the base? The base is from F to what? F to? No. The base of the triangle is from F to D. And where's the height of the triangle? The height must always be 90 degrees to the base. So what I need to do is I need to draw a 90 degrees line. And you will agree that this is 90 degree, right?
Yes.
Okay, so the height should be here. Now, let's talk about the green triangle. Let's look at the green triangle here. Where is the base of the green triangle? Is it the same as the yellow triangle? Yes, it has the same base. What about the height? If I draw a 90-degree line from the parallel line on top to the parallel line below, this is 90 degree. Can I say that this is the height of the green triangle? So does the green triangle have the same height as the yellow triangle, Nicholas?
Yes.
Very good. So that means they have the same base, they have the same height. Do they have the same area? Same base, same height. That means same area. Yes or no?
Yes.
Yes. Very good. So if you have the same base and the same height, you have the same area. So in order to find, okay, so let me erase this first. Same base, same height, same area. So if they have the same base, same height, and same area, do you notice that this part is an overlapping part?
Yes.
So if I want to find the area of the yellow wing, the yellow butterfly wing, I need to take the triangle minus the overlapping part. If I want to find the area of the green color wing, then I take the triangle minus the overlapping part. Since the area of both triangles are the same, will you say that the yellow and the green have the same area also?
Yes.
Yes, correct. So then what is the answer? What is the area of the yellow part?
Yeah.
Well done. So Nicholas, now you understand how to use the butterfly concept?
Yes.
Good job. Anyone has any questions? Raise your hand, students. Anyone? Okay, just look out for parallel lines and look out for the triangles inside the parallel lines. Same base, same height, 90 degrees, and you will have the same area. Okay? So what is the next thing that we need to learn? Besides the butterfly concept, we are also going to learn about trapeziums. So this is a trapezium, students. What is a property of a trapezium? It has 4 sides, and it also has a set of parallel lines. All right. Now, they already gave us the formula here, how to calculate the area of a trapezium, but I do not want you to use the formula. Let's just hide the formula for a while. Let's just look at the trapezium by itself, okay? Kate, can I ask you something? If nobody told you the formula, and I just show you this shape like this, do you know how to find the area of this shape? If I did not tell you the formula, will you know how to?
No.
What if I drew a line like this? then will you be able to find the shape of the area of this trapezium? It is just two, what shapes do you see?
Two triangles.
Two triangles, correct. Do you know how to find the shape of a triangle? Do you know how to the area of the triangle? Do you know how to find?
Times their base times their height.
Yeah, so if you know how to find the area of a triangle, you can just find the area of triangle A and you find the area of triangle B. You add
Put them together.
them together and it becomes a trapezium, right? Right, Kate?
Yeah.
Yes. Yes, Abby, you're raising your hand. Is it Abby?
Yes. For me, I put two lines, which is three equilateral triangles.
So you usually do this and you do this and you form three equilateral triangles.
Yes.
Do you know what is the meaning of equilateral triangle?
Yeah.
What?
All sides are equal.
All sides are equal. And what about the angles?
All angles are equal.
And what is the angle exactly?
60 degrees.
Correct. How sure are you? How sure are you that this is 60 degrees? What if I drew a trapezium that looks like this? Are you still able to tell me that this is 60 degrees?
No.
No. So can you guarantee that you are going to get an equilateral triangle?
No.
No. Yes, you can split it into three triangles, but you cannot say that it is an equilateral. Okay, Abby?
Okay.
Very good. So students, it's good that Abby shared what she does. Okay, you can also choose to split it into three triangles. It's up to you. You can even split it like that if you want. You can get one rectangle.
Keep the shell though.
Sorry?
I want to show that.
You can even split it into a rectangle plus two triangles if you want. But the reason why I do this is because it is faster. It is faster because
You don't have to determine if it is an equilateral triangle or not.
yeah, you don't have to. Actually, it's not compulsory to get equilateral triangles. And also what? Furthermore, I only need to find the area of two triangles, and I add them together. Because if you divide it into so many shapes, then you need to do more workings. Am I right? So that's why I prefer to divide it into two triangles. And let's say that this is 5 cm. Okay, let's say this is 7 cm. Let's say this is 10 cm. And let us imagine that the height, okay, let's just imagine. Okay, these are two parallel lines anyway. So the height is always the same. Let's just imagine that the height is 5 cm. Okay, can you help me to find the area of triangle A, Kate?
Triangle A is 25.
Half times the base times the height.
R equals 25.
Very good. Let's find the area of triangle B.
And then we have half times 7 times 5
Okay, the base is 7
equals
to
35 times half.
35 divided by 2.
Yeah.
Okay, 35 divided by 2. So when you want to add them together, okay, we just add 25.
We get 42.5.
Yes, very good. So the area of the trapezium is 42.5. I have one more question for you. You took half times 7 times 5. That means the base is 7, right? But when you talk about the base, must the base be at the bottom? Must the base be always at the bottom?
No.
No, very good. Students, sometimes the triangle can be upside down. Sometimes the base can be on top. As long as the height is 90 degrees to the base, then you can find the area. The base does not always have to be at the bottom. It can be anywhere. Okay?
Okay. Also,
Oh.
which page is this problem?
It's not a problem. Actually, this is just page 1. It's just page 1.
Okay.
It's not even a problem. I'm just teaching you a concept. So, Kate, let's continue. We already found the area of the trapezium, 42.5. Now I'm going to take a look at the formula that they gave us. Half times the sum of the parallel sides times the height. So let's try this formula, okay? The area of the trapezium is half times the sum of the parallel sides times the height. Can you tell me what is the sum of the two parallel sides? What plus what? Okay. What is the length of the two parallel sides, Kate?
Two parallel lines would be half times height.
No. The length of the two parallel sides. This one, the sum of the parallel sides. This is a parallel side. This is a parallel side.
7 and 10.
Okay, then times the height. What is the height?
5.
The height is 5. Very good. Come, let's work it out. Half
equals 42.5.
Do you notice that we get the same answer?
Yes.
Oh, very good. So now what I've just shown you is the formula works. Okay. If you want to do it a little bit longer, you want to take 2 steps or even 3 steps to do it, then you can find the two triangles separately and you add them together. But if you use the formula, all you need to do is you add the sum of the parallel sides, 7 plus 10. You will still be able to get the same answer and you only need to use 1 step. Right, Kate? All right. Do you have any questions about trapezium?
No.
Okay, thank you, Kate. How about the rest of you students? Anybody have any questions about the area of a trapezium? Okay, you just need to add the sum of the parallel sides. So now let's try to do a question that involves a trapezium. All right, let's take a look. This one. Okay, if I want to find the area, the question is asking you to find the area of triangle ADE. Okay, so they are asking you to find the yellow triangle. Hence, can I ask Junyi? Okay, Junyi, do you have any idea what steps must I take to find the yellow triangle? You already know there's a trapezium, right?
Yeah.
Okay, so let's draw the parallel line here, trapezium. Okay lah, let me ask you step by step. Are you able to find the area of this trapezium first?
Yes.
Oh, very good. Do you remember what's the formula?
Half times the parallel lines.
Half times the sum of the two parallel lines, then multiply by the
Height.
good. So this is the correct formula. Come, let's try to find the area of this trapezium. Half times. Can you tell me which are the two parallel lines?
10 and 6.
Oh, very good. And what is the height?
6. 10.
Okay, help me to calculate what's the answer for this.
80.
Got it. Okay, well done. You found the area of this trapezium. Now, you already have the area of the trapezium. You want to find the shaded part, right?
Yeah.
So you must minus something. What must you take away?
ABE and DEC.
Okay, let's label this as triangle X and triangle Y. You must take the trapezium minus the area of X minus the area of Y. Let's take a look. Do you know how to find the area of X? It's a triangle, right?
Yeah.
Okay. Which one do you want to say is the base?
10 cm.
Very good. Let's say that this is the base of the triangle. That means the height must be 90 degrees to the base. Do you know the height?
No.
Okay, never mind. You don't know the height. Let me point something out to you. Oh yeah, just want to remind you, after class, right, I'm going to email the full solution and all the working to your parents. So during class, don't worry about copying the steps. We will not worry about that. We will just focus on learning and asking questions. So I want to point this out to you, Jinny.
Yeah.
BE is over here and EC is over here. What does that line mean?
They are equal.
They are equal. Very good. If they are equal, then do you agree that point E is in the middle of B and C?
Yes.
And if it is the middle, right, then if I cut the 10 cm into half, what do you think is the height here?
5 cm.
Excellent. Excellent. So now do I know the height of the triangle?
Yes.
Very good. Okay. So the height of the triangle is 5. So now let's try to find the area of triangle X. Half times what is the base?
10.
What is the height?
5.
And you get 25. Now let's find the area of Y. Half times what is the base?
6.
What is the height?
5.
Okay, so now you want to find the shaded area. Okay, or actually it's not shaded. It's just called triangle ADE equals. Can you tell me what workings must I do?
25 plus 15.
No, just immediately find the area of triangle ADE. What minus?
80 minus 40.
Yes. And the answer is?
40.
Well done, Ginny. So, do you find this easy or difficult?
Easy.
Well done. Any questions? No. How about the rest of you? Anyone have questions? Raise your hand. Okay, you can see that we already know how to find area of trapezium. And I think the most tricky part, because at first we didn't know what's the height. We did not know what is this height. So I think the most important part of this question is that you need to look at this line here and this line here, okay? If they are equal, that means point E is in the middle. So you cut it into half, you get 5 cm. So let's try this one. Okay, students, for this, it is a different concept that I need to teach you. So let's take a look, all right? The question is telling us that AB equals to 3 out of 7 of AC. Okay, so this is AC, students. And this is AB. Let me ask Talia. So Talia, look at the fraction here. AB, the length of AB is 3 out of 7 of the total length of AC. Can you tell me, Talia, how many units are you going to give AC and how many units are you going to give AB?
AB 3 units, AC 7 units.
Well done. Okay, so we say that AC is 7 units and AB is actually 3 out of 7. 3 out of 7 of AC. Okay, so the question is telling us that AB equals to 3 out of 7. That means AB must be 3 units and AC must be 7 units. And therefore, Talia, what about BC? How many units is BC?
4 units.
Good job. 4 units. So students, now we already know how many units are they. Okay, the next thing that I want to do is this. Okay, Talia, ignore the question for just a moment. Okay, I'm going to draw a different triangle. Okay, let's say I draw something that looks like this. Let's say I tell you that this is 2 cm. Let's say I tell you that maybe this is 5 cm. Maybe I'm going to tell you that the height, okay, the height of the triangle is 4. Okay, so Talia, now, if I call this triangle A and I call this triangle B, can you help me to find the area of triangle A? Half times
4 times 5.
half times the base times the height. And what do you get?
10.
Now, let's find the area of triangle B. Half times the, what is the base?
2,
And the height.
4.
And what do we get?
4.
Now, very good. Let us compare the area. Compare the area of A and the area of B. The area of A is 10. The area of B is 4. The ratio is 10 is to 4. Can you simplify this for me, Talia? The ratio?
5 is the 2.
5 is to 2. Very good. Look here, 5 is to 2. Look here. What do you notice? The ratio of the area is same as the ratio of what?
The base.
Very good. Students, very important. Please pay attention. Look at the base. 5 is to 2. 5 cm and 2 cm. Then the area also have the same ratio. The ratio is 5 is to 2. Why do you think the ratio is going to be the same, Talia?
Because they have the same height.
Excellent. Because the two triangles have the same height. Whenever the triangle have the same height, the ratio of the base is the same as the ratio of their area. So we are going to use this trick. We are going to use this trick to solve the question. Okay, students? Let me just make some space and... okay, let me just get rid of this. So we know that these two triangles have the same height. Okay? So if they have the same height, then the ratio of the base is going to be the same as the ratio of the area. So Talia, as you can see, let's call this triangle A and call this triangle B. Okay, the area of triangle A compared to triangle B, okay, the ratio should be 3 is to what?
3 is to 4.
Because this is the ratio of the base, okay? So if you right now you already know the area of A is 31.5. They are asking you to find the area of triangle B. Correct? So you can say that 3 units equals to, we already know, you already look here and you can say 3 unit equals to what area?
3 units equals to 31.5.
Yeah, so 1 unit equals to 31.5 divided by?
Divided by 3.
Yes. Then they ask you to find What is the area of B? How many units is that? How many units is the area of B?
5 times 4.
Correct. You need to find 4 units. And therefore, you multiply it by 4, you get 42. So is this your answer?
Yes. No. Wait. Yes. No, wait,
Well,
no. No, I mean yes.
well done, Talia. Okay, you got it. Talia, you have any questions about this?
No.
Okay, good job. Junchen, yes, you raise your hand.
Can I go to toilet?
Go ahead. Okay, so students, what is the most important thing here? It does not mean, okay, if it does not mean that if I draw one triangle here, then I draw another triangle here, then I tell you that this is 3 and this is, let's say, 2. It does not mean that any random triangle, then you can, it does not mean any random triangle, you can just say that the area is 3 units and 2 units. You cannot just do this for any triangle. What is the key point here, students? Can everybody type in the chat group? How come I can say that the area of the base is same as the area, the ratio of the base is same as the ratio of the area? What is the important thing here? Can you type in the chat? How come I can just compare the ratio like that? Can I do it for any triangle? No, there must be, yes, Talia, very good. Who else knows? What kind of triangles can I compare? This only applies to triangles with the same what? Students, everybody, can you type? Abby, you got it. This only applies to triangles with the same what? Okay, by the way, this is wrong. We cannot just do it for any random triangle. This can only be done for triangles with the same. Yes, Nicholas, very good. Maximus, you are not, I don't think you're correct. You don't need to have the same base and the same height. Same base and same height immediately has the same area. But I'm not saying that these two triangles have the same area, you know, Maximus. Okay, students, you only can apply this method if you have two triangles of the same height. Whenever the two triangles have the same height, then you can say that the ratio of the base will be the same as the ratio of the area, students. Okay? Make sure the triangles must have the same height. Don't worry, we'll do more practice for this. Okay, let's look here. Immediately when you look at this diagram, students, okay, we already know. Okay, look here. We already know that this triangle X and triangle Y, both of them will have the same 90-degree height. Okay, look at triangle Y. Triangle Y has a base over here. This is the base of triangle Y. The height is 90 degrees. Now let's look at triangle X. The base of triangle X is over here. The height is the same as triangle Y. The height is 90 degrees to the base. Therefore, triangle X and triangle Y have the same height. Okay? If they have the same height, that means the ratio of their base will be the same as the ratio of their area. It's the same thing applies to the green color triangles. You look at the two green triangles. Triangle P and triangle Q, they have the same height. 90-degree height. Okay? Triangle P and Q have the same height. And therefore, you can say that the ratio of the area is the same as the ratio of the base. So I'm going to use this concept to solve this question. They are telling us that ABE is 64 centimeters square. The area of ABE is 64. The area of AED is 32. The area of CED is 35. Okay. So we have all those numbers. Now we can look at 64 and 32. 64 and 32. That is the area of triangle ABE. And we are comparing it with AED. 64, 32. The ratio is 2:1. So immediately, since we know that the ratio is 2:1, that means the ratio of the base is also 2:1. Any questions so far? The base is also 2:1, same as the ratio of the area, because they have the same height. Yes, Ben, question.
Can I go to the toilet?
Yeah, go ahead. Okay, so students, 2:1, huh? So if you look at the green triangles now, you already know that the base is 2:1. Can you find the area? Can you find the missing area here, students? Can you type for me in the chat group? What is the area in the question mark? Everybody type in the chat group. What is the area of the question mark? Maximus, I want the question mark. I want the question mark, Maximus. Triangle BCE. Tell me what is the area of triangle BCE. Everybody. Okay. Let me draw this for you. I'm drawing the green triangle. I'm drawing the green triangle, okay? This is 35. So what should this be? Look at the ratio, students. 1 unit equals to 35. So 2 unit equals to 70. So now we know that triangle BCE equals to 70. So what is the area of the quadrilateral ABCD? All you need to do is add everything together and you will get your answer. All right, students. So what is the important thing we learned here? When the two triangles have the same height, the ratio of the area is the same as the ratio of the base. Since this is 1 unit and this is 2 units, that means 1 unit equals to 35, 2 unit must be 70. And I'm looking in the green color triangle. I'm looking at the green triangle now, not the other one, the green one. So when you add everything together, you will get the area of ABCD. All right. Any questions, students? Raise your hand. Okay, no questions. Then let's try example 4. Example 4 is also making use of the same concept, students. Let me ask Abby. So Abby, they want us to find the shaded region, right? you already know that there's a square. And they even told you that the side of the square is 6 cm. So Abby, you can find the area of this square, right, Abby? What is the area of this square?
36 centimeters squared.
Yeah. Correct. The area of the entire square is 36. So if you want to find the shaded area, you need to take away the triangle here, and you need to take away the triangle here. Am I right, Abby?
Correct.
Now, are you able to find the area of this triangle here?
Yes.
You already know the base. Do you know what is this? The height? You don't. Okay, no problem. If we don't know the height, let us read the question. The question says that BE equals to 2 times of CE. Now, what does this mean? BE equals to 2 times and CE is 1 time. So that means CE has 1 unit, BE is 2 units. Do you agree?
Correct.
And they also told us that DF equals to 2 times of CF. DF is 2 times, CF is 1 unit. Yes or no?
Correct.
And you also know the entire length is 6 cm, right?
Correct.
So can you find the height over here?
Yes.
How many cm?
2 cm.
Yes, this is 2 cm. So obviously we can now find the shaded triangle. Half times the base times the height. Okay, you already found the shaded area 6 cm square. But can you find this one? You still need to minus the other part, right, Abby?
You can
Okay.
find that one.
Okay, you know that 2 unit is 4 cm, correct?
Correct.
What about the height? This is the base, okay? Let's say you already know the base here, 4 cm. What is the height? 90 degrees, right? The height must be 90 degrees to the base. So let me erase this. If I want to find the height of, if this is the base, then if I want to find the height, it must be 90 degrees. So this is the height. Do you know what is this height?
2 centimeters.
Well, I will agree with you if you tell me that this is 2 centimeters. But if you try to tell me that this is 2 centimeter, I will disagree. Because this line is a slanted line, Abby. Can you see that the line is slanted?
Yes.
How can this be 2 centimeters? It is definitely less than 2 centimeters. So can you find the height?
No.
No. So we cannot find the area, right? So if you cannot find the height, you cannot find the area, how are you going to find the shaded part then? So this is not so straightforward, right?
Right, so do you figure out the area of the shaded part?
How do we directly figure out the area of the shaded part? I don't think we can. It is of a very odd shape. It is not a trapezium, it's not a square, it's not a triangle. It's a very funny shape. Even if we divide it into a triangle, do I know what is the base? And do I know what is the height? I don't. That will not work. Even if I divide it like that, do I know what is the base here? Do I know what is the height here? I don't. So that's not the way to do it. Any ideas, Abby? Or any one of you? Any ideas? Raise your hand. Think about it for a while. Anyone? Yes, Kate, you have an idea. What is it?
I want to ask is 2 units equals 4 cm.
Yes, correct. Oh, very good, Nicholas. Nicholas said butterfly. Okay, let's draw a butterfly. Parallel line here. Parallel line here. These are parallel. That means the height is 90 degrees here. which is the same. So since we already have a butterfly, this area is equal to this area. Yes, correct. But even if it is equal, right? So what? I don't know what is the base. Okay, look at the base here. And I also don't know what is the height. I'm still stuck. Even though I know that there's a butterfly there, I'm still stuck. It doesn't help me. Okay, student? Okay, since nobody has ideas, why not I draw some lines? First, I'm going to draw a line here. Why am I doing this? I want to get triangle A and triangle B, okay? And I want to make sure that they have the same height. 90 degrees height. If the height is the same, that means the ratio of the area is the same as the ratio of the base. Correct, students? We just did this, right? We just did this, right? The ratio of the base is the same as the ratio of the area. So, if I do this, what can I do? I already know they have the same height. I can immediately say that the area here is 1 unit and the area here is 2 units. Okay, students? Same thing for this one here. 1 unit here, 2 units here. Okay? Now, we already know that the unshaded part has a total of 6 units. Can I ask Ben? Okay, the unshaded part have a total of 6 units. Ben, do you know how many units are there altogether in the entire square? Can you find that? Do you think you can tell me? In the entire square, how many units are there altogether?
Is it including the inside also?
Including the shaded part and also including the unshaded and also including the shaded, everything. How many units do you think there are altogether, Ben?
Um, um, 24.
How do you know it's 24?
Yes.
You are correct, Ben.
No,
What?
because the unshaded part was 6 units, so I thought the rest the the unshaded part was 3 more of the unshaded part, so I just 6 times 3.
Oh, wow. Okay, let's look here. Look at this yellow triangle. How many units are there in this yellow triangle?
6.
4 units. Okay, very good. Okay, look at this 2 unit. 2 unit, I'm going to split it into half, okay? Cut it into half. This become 1 unit, this become 1 unit. Draw a line here. Okay, draw a line here. It's at the halfway point. I would also like to draw another line here. Now, Ben, tell me, inside the green color triangle, how many units are there altogether?
Yeah.
Is the green color triangle same as the yellow triangle?
Yes.
Yes, definitely. How many units are there altogether in the green triangle? Huh? What?
4.
Very good. And if I continue to cut them into triangles, or you don't need to cut into triangle, look at the entire rectangle. Okay, look at the entire rectangle here. How many units are there altogether in this rectangle?
8.
8. How many rectangles do I have?
Three.
3 rectangles. So the total area is 8 units multiplied by how many rectangles?
3.
Yes, that means I have 24 units in the total area. What about the shaded area? How many units are there in the shaded area altogether? 24 minus how many?
Plus minus minus 6.
Very good. Minus away the unshaded part. That means now you know that the shaded area is 18 units, right?
Yeah.
Well done, Ben. Well done. So we know that the total area is 24 unit. The total area is the big square. What is the area of the big square? You already know that the side is 6 cm, right?
6 times 6.
6 times 6. So you know that the area of everything is 36 cm square. So now I want you to find what is 6 units. Okay, can you help me to find what is 6 units? That means you need to divide by how many? 24 divide by?
4.
Yes. So if you divide by 4, you will get, okay, 36 divided by 4. How many cm is that?
8, 9.
Correct. 6 units is 9 centimeters square. Now you can find the shaded area, 18 units. Multiply by how many?
9.
Multiply by how many?
Not
6 units multiply how many?
9. Wait.
6 times what is 18?
2.
6 times what is 18?
8.
6 times 3 is 18, right?
Yeah.
So now you want to find the area. What do I get?
27.
Well done. Good job, Ben. So Ben, did you find that this question was quite difficult at the start?
A bit.
So after drawing the lines, did it make it easier?
Yeah.
Well done. Any questions about this?
Mm,
No? No question? How about the rest of you? Any questions? Raise your hands. Okay, good job. So students, what concept did we use here? We make sure that the two triangles have the same height. And then the area will be, the ratio of the area will be the same as the ratio of the base, as long as they have the same height. Okay? Then we can split them up into units. That's how we solve it. Now, over here, let's take a look. There is another concept that we need to know. Junchen, can I ask you something? Let's say I have a rectangle, Junchen. If I draw a triangle inside this rectangle, can you tell me what fraction, okay, let's shade it. What fraction of the rectangle is being shaded right now? Can you tell me?
Half.
Half. Oh, very good. How do you know it's half? Okay, let's prove it. Okay, let's prove it. Let's draw some lines and prove it, okay? Now, how do I know it's half? We draw a line here. Okay. Then we say that, okay, Junchen, is this area the same as this area? Junchen?
Yes.
Yeah, Kate, go ahead. And is this area the same as this area?
Yes.
Very good. That means the shaded area must be half of the entire rectangle. Well done. So what did we learn from here? We learned that whenever you see a triangle being drawn inside a rectangle, then the area of the triangle is half of the rectangle. Half of the rectangle. So let's take a look here, Jinsen. In order to do this question, why not I do some labeling? Okay, let's use a different color. A, B, C, D. Wait, let me just do it again. A, B, C, D, E. Okay? Now, Junsen, do you agree that if I take A plus C plus E, it is a triangle which is inside a rectangle, right?
Yeah.
So shouldn't it be half of the rectangle?
Yes.
Okay, yes, correct. Now, I would like you to look at this part here. Let me see. I want you to look at this part here. The yellow part. Will you say that the yellow part is half of the rectangle? Yes or no? Yes or no? Or you're not sure? Jinsen, do you know? Okay, never mind. Let's look here.
It's
You
half.
answered, yes, it is right because you already say that the triangle is half. That means this part, the yellow part, should also be half. Yes or no, Jinsen?
Yes.
Correct, correct. So let's take a look at the yellow part. I'm going to add everything together. 13 plus A, right? Plus what else, Jinsen?
13
13.
plus A plus 49
Okay, what else?
plus B.
No, B is not the yellow part.
No, plus 35 and plus E.
And will you say that this is half of the rectangle?
Yeah.
Yes, right? Yes, okay, it's half of the rectangle. So can you help me to take this plus this plus this? What do you get? 97. Okay, so we get 97. So I say I have an A here plus 97 plus the E, and I'm going to get half of the rectangle. Jinsen, you compare this and you compare this. Can you tell me C equals to how much?
37.
Very good. So obvious. Well done, Jinsen. Jinsen, do you have any questions about this?
No.
Thank you, Jinsen. So students, whenever you see a triangle in a rectangle, then the triangle is half of the rectangle. You can use this to your advantage and you can solve the question by comparing. Compare the alphabets. You just need to compare the alphabets. I have already shown you method number 1. Okay, for method number 1, what did I do? I use the triangle ACE. I use the triangle ACE and I compare it with the yellow shaded part. Correct, students? I want you to now try another method. I want you to now use the triangle BCD and I want you to compare it with the other yellow shaded parts. Can you all compare it? Okay, let me ask Kate. So Kate, we are using triangle B, C, D right now. Okay? And we say that this is half of the rectangle.
Yes.
So now we already did that. let's use the other yellow shaded part. Can you tell me what are inside the yellow parts? Let's start from
Inside the yellow parts are
here.
35 plus B plus 49 plus 13 plus D
Okay. Now
equals half.
yes, correct. So we take 35 plus 49 plus 13. We will get 97. So now I'm going to write down B plus 97 plus D equals to half. Do you
This is, oh, okay.
do you
I
agree?
get it. Yes.
Because we already added all the numbers together and we got 97, right? So now you compare this and you compare. What are you going to say?
C equals 97.
Well done. So Kate, do you see that there's two methods that we can use? And both of them will work, right?
Method 1 is more efficient because there's less equations.
No, both are the same.
Oh yeah, that's true.
We are just using different triangles, that's all. But the whole thing, the whole point that I'm trying to prove
Okay.
is that you can use any triangle. It doesn't need to be ACE. You can also use BCD, right, Kate?
Yes. Actually, you can use any third triangle.
So, Kate, do you have any questions about this?
No.
All right. Well done. How about the rest of you? Does anyone have questions about this? Okay, nobody? Then let's try the next one. Students, this is quite simple. Okay, let's draw a square first. And I'm going to draw another square inside. Okay, Maximus. Can I ask you something? Okay, look at the yellow square. Okay?
Me?
If I tell you that the big square has an area of 50, can you tell me what is the area of this yellow square, Maximus? Do you know? I already tell you that the big square is 50. The area is 50. Then I'm asking you what's the area of the yellow part?
Half.
Half. Very good. It is half because if I draw a line here and I draw a line here, how many triangle do you see altogether? Altogether.
8.
8 triangle. What about inside here?
The 4.
4 triangles. Correct. Therefore, we can say that if I have a small square inside a big square, the small square is half of the big square, right, Maximus?
Yeah.
Okay, so using this concept, we can look at the question. Can you first tell me what is the area of the biggest square?
50.
Sorry?
8 minus 8.
8 minus 8. 8 minus 8, huh?
No, 8 times 8.
Yeah, 64. Okay, so now you know that the biggest is 64. Then what about the second biggest? The second biggest is how many?
Second biggest square.
Yeah, should be half of the first one, right? So
Wait,
how much?
4 times 4.
4 times 4. What is the area of the second biggest one?
4 times
It should be half of the first one, right?
64
So you just need to divide it by 2 and you get 32. What about the next one? The next one inside.
Square.
Yeah, the next square. How much is the next square? What's the area? It should be half of.
16.
Yes. Then the next one.
No. 8.
And the final one.
4.
Very good. So we have found the answer, which is just 4. So how, Maximus, do you feel that this is easy?
Oh, yeah.
Yeah. Yay, you got it. So students, any of you want to ask any questions about this? Whenever you see a big square in a small square, it is half, right? Now let's try the next one. Students, this is super easy. 1 minute, give me the answer. Well done, Abby. Junyi. Okay, Junyi. Now, what shapes can you see here? You see a square. Okay, that's number 1. What other shapes can you see?
Half a circle.
Yes. What else? Do you know what is this funny shape here?
No.
It's a funny shape. Alien shape. Okay, we don't know what shape that is. What about this shape here?
Half of a circle.
Quarter circle. Right?
Yeah.
What about this shape here?
Half of that funny shape.
Oh, it's good that you said that. Very good, Junyi. Look, I draw a line. Do you agree that this shape is the same as this shape?
Yes.
What can I do? So what can I do? Can I move it here? Do you think it will fit in?
Yes.
Okay, let's do it. Let's move this here. It will fit in and this will become a shaded part. Yes or no?
Yeah.
Can I do the same here?
Yeah.
Now I move it in. This becomes a shaded part. In the end, what is the shape of the shaded part now?
A rectangle.
So all you need to do is find the shape of this shaded rectangle, right, Jenny?
Yeah.
Okay, you tell me what is the length here?
25.
25. So the area of the shaded region, what is the workings that I must do?
50 times 25.
And I get 1250 cm squared. So how, Jenny, do you agree that this is easy?
Yes.
Well done. So students, as long as you imagine cutting the thing into half and you move it into the slot, then you will get a very nice rectangle. You don't need to worry about circles, right? Okay. Let's try the next one. Okay, let me ask Nicholas. Can you volunteer for this? So, they want you to find this the shaded region. Can you tell me what shape is that shaded region?
2 triangles.
It's 2 triangle, right? It's some funny arrow kind of arrowhead shape. Do you know any formula to find an arrow shape?
No.
Nah. So instead of finding the area of the funny shape, why not we stick to shapes that we are familiar with? We are familiar with squares, right? We are familiar with rectangle, we are familiar with squares. Are we familiar with triangles?
Yes.
We are also familiar with triangles, right? So what strategy will you use to find the shaded area? Can I find the total area of everything first?
Yes.
Okay, so let's say I find the total area of this, the rectangle plus the square. Then if I want to find the shaded part, what must I take away?
Two triangles.
Very good. You must take away this triangle and you must take away this triangle. Then you will find the shaded part. Easy or not?
Yes.
Well done, Nicholas. Thank you. Students, this is easy. I'm going to let you try this as homework. Okay, once you do it, you just ask your parents to take a photo and send it on WhatsApp, and I will take a look at your workings. It's too easy, all right? Now, let's try this one. Okay, look at that shaded part. They want you to find the shaded part. Now, again, students, remember remember the previous question that we did here? We actually moved the shaded part to fill up the empty space. We can do the same here, you know. What if I draw a line here? Okay, let me ask Talia. So Talia, if I were to draw a line here, do you think that I can take this triangle and move it into this space here? Yes or no?
Yes.
How do I know this? How can you confirm that they are the same? Okay, let's check. Okay, let's check. The base, do they have the same base?
Yes.
Very good. And now, do they have the same height?
Yes.
90 degree here, 90 degrees here. Very good. So, in order to find the area of the shaded part, what shape are we trying to find essentially?
A rectangle.
Yeah, correct. So we draw a line here. We just need to shift this here and you end up with a rectangle. So easy. Thank you, Talia. Does anybody have any questions so far about this? You just need to find a rectangle. Anyone have any questions? Raise your hand. Okay. This is very easy. I'm sure you all can do it. So this page is the homework page. I need you all to try these two questions and send to me a picture of your workings on WhatsApp. Okay, so, your parents will be able to WhatsApp us. Now, students, look at this. This question is not easy. I will be going through this with you. Okay, take some time to read it first. Let me ask Abby. So, the question wants us to find the area of the shaded part. Okay, they are telling us that the triangle here has an area of 2 cm square. This has an area of 8 cm square. They did not tell us this. If they had told us the area of this, it would be super easy, right? Because we already know that the entire area of the rectangle is 32. So essentially, if I know that the entire is 32, I just need to minus 2 cm, minus 8 cm, and I just need to minus this. Then I can get the shaded area, right, Abby?
Correct.
Our problem now is that they didn't give us the yellow triangle. Any ideas? How should I find this yellow triangle, Abby? Do I know the height? I don't even know the base. I don't even know the height. I'm stuck. And that's what makes this question difficult. Okay, think about it. Let me know if you have any ideas first before I tell you the answer. If anyone have any ideas, you can just raise your hand. Yes, Abby. Very good. Okay, come, Abby. You have a very good idea, okay? Now, Abby, you told me in the chat group that we need to draw some lines. Now, Abby, what if we drew a line here and cut the entire thing into half? Will you be able to tell me the area of the triangle ADC? Yes or no? You know that the entire rectangle is 32, right? So, Abby, can you tell me the area of ADC? The triangle ADC, Abby? Do you know what is the area of ADC?
10 centimeters squared.
16. Yes. Let me write it down. Triangle ADC has an area of 32 divided by 2. Okay, so it is half of the rectangle, 16 cm square. Now you compare this to triangle ADF, and I realize that triangle ADF has an area of 2. Now, the ratio, can you help me simplify the ratio, Abby?
You could simplify it to 8 versus 1.
Very good. 8 is to 1. My next question to you is this. You look at this triangle here, the yellow triangle here, and you compare it to the green triangle. Do you think they have the same height? Do they have the same height, Abby? 90 degrees?
No.
No?
No.
Let's look at a triangle that looks like... If this is the base of the triangle, can I say that the height of the triangle is here, Abby?
Oh, yes.
So do you think the yellow triangle has the same height as the green triangle?
Yes.
Yes, they have the same height. Now, what did we learn about same height? If two triangles have the same height, the ratio of the area will be the same as the ratio of their what?
Base.
Their base. So you already found the ratio, right? 1 unit. And how many units should be here, Abby?
8.
8. Are you sure it's 8?
Yes.
Look at this. What is this? ADC. Where is ADC?
Uh,
ADC
7.
7. Yes, this must be 7. Very good, very good. Okay, good. Done. Now, let's look at the next one. Okay, I'm going to erase the yellow and the green. I'm going to look here now. This is going to be a green triangle now. And this is going to be a yellow triangle now. Abby, do they have the same height? Do they have the same height?
Yes.
Yes. Okay, so this is the base of the green triangle. This is the base of the yellow triangle, right? Okay, can you see that this is the base of the yellow triangle? And this is the base of the green triangle, and this is 90 degrees, yes?
Yes.
Okay. What is the area of the yellow triangle, Abby? Do you know?
8 centimeters squared.
8 centimeters squared, correct. The reason why the yellow triangle is 8 cm square is because half of the rectangle is 16. Okay, 16, then you minus the green triangle. The green triangle is 8. So it's 8. So both of them have the same area. Do you think they will have the same base, Abby? If they have the same area, do you think they have the same base?
Yes.
Yes. Correct. They will have the same base. Very good. So now I already found 1 unit, 7 unit, and 1 unit, 1 unit. My purpose now is to find the rectangle over here. Okay, never mind. Let's find this rectangle first. Abby. Okay, never mind. I'll draw a totally new rectangle. I know that this is 1 unit, this is 7 units. And I know that the total area is 32. Right?
Correct.
Okay, so what's the next step? Can I say that 8 units equals to 32? Because the entire length is 8 units, right?
Yes.
So if I just want to find this, that will only be 7 units. Am I right?
Yes.
Okay, let's find 1 unit. 32 divided by 8. That's 4. So 7 units equals to how much?
28.
Well done. So now I know that because the ratio is 1 and 7, okay, that means this is 28 and this is 4. So far, any questions? Anyone? Any questions? If you're unsure, please raise your hand now, okay? Okay, so everybody agrees that that is 28. Okay, we have 28 here, Now, Abby, my next thing that I want to do is this. We already know that this is 28. Can I cut it into half and tell me what is this shaded area here, Abby?
14.
Very good. So now you already know that this is 14. Okay lah. Why not I don't cut it into half? Why not I do this? Abby, can you find the yellow triangle?
7.
Well done. So triangle, okay, triangle FCE equals to 28 divided by 4, 7. So now can we find the shaded region, Abby?
Yes.
Okay, tell me the workings.
Um.
The entire rectangle is 32 minus Abby?
Minus 7 plus 2 plus 8.
Okay, what answer do we get?
32 minus 17, which is 15.
Well done, Abby. So do you agree that this question was quite challenging?
Correct.
Yeah. Do you have any questions about it?
No.
Okay, good job. How about the rest of you students? This is not so easy, right? But do you all understand what I said? If you have questions, please raise your hand now. Anyone? Okay, looks like nobody. Okay, students, we have already done the butterfly question. Now, let's take a look at this one. Remember just now, we actually said that when we draw a triangle inside a rectangle, this triangle is actually half of the rectangle, right? Now, it is the same thing if I draw 2 different triangles. Okay, let's draw some triangles. Okay, I'm going to draw some random triangles, okay? Students, it might not look like half, but I can tell you right now that the yellow part is actually half of the rectangle, you know. Okay, can I explain? Let's prove it. Okay, let's prove it. Why? Why is it half? Can you see that this is just, can you see that there's actually 2 rectangles? There's 1 rectangle on top, 1 rectangle below. The rectangle below The rectangle below has a triangle inside. The rectangle on top also has a triangle inside. Okay, students? Definitely half. So please make use of this. Make use of this concept. It's very easy once you make use of this concept. And I'm going to let you try it as a homework. This question, okay, students, this one. Actually, it's very easy. But if you cannot imagine and if you cannot visualize, it will be very hard. So this one is a bit tricky, you know, it really depends on whether you can visualize it or not. I'm not going to give you the answer just like that. I will let you try it. And let's see whether you can visualize. Okay, if you can't, it's okay, because I'm still going to send the solution to your parents. Then you can see the correct way to do it. But please don't look at the answer before trying. Just try first. If you really cannot, then you look at the answer. Okay, now let's look here. All right, let me ask Ben. So Ben, can you volunteer for this?
Okay.
First, we are going to look at this triangle, the yellow triangle. Do you agree that A and B have the same height? Yes or no?
Yes.
Very good. Let me draw it here. 90 degrees, right, Ben?
Yeah.
Okay, so if they have the same height, that means the ratio of the area should be the same as the ratio of their of the base. Okay? Okay. The same thing applies for D and C. They have the same height, 90 degrees. The ratio of the area is the same as the ratio of the base. The question tells us that the ratio of ABC is 3 units, 5 units, 2 units. So how many units is D? What do you-
I
Sorry, 5. Is it 5?
think so.
Do you agree that C plus D is half of the square?
Yeah.
Can you see that there's a line here?
Uh-huh.
This line actually cuts it into half, yes or no?
Yeah.
So if there's 8 units here, then how many units should there be altogether? 8, right?
Yeah.
So how many units is D? How many units is D?
6.
6, correct. How many units are there altogether in the square?
16.
Okay, so you know that 16 is 96. So 1 unit is 96 divided by what?
16.
And we get
Um,
16. 96 divided by 16 units. Okay, we will get 6. So we know that 1 unit is 6. So what is the area of B? How many units is that?
5 times 6 equals 30.
Sorry?
5 times 6.
5 times 6. Are you trying to say that this is 5 units? How many units is B?
B or D?
Oh, sorry. They're asking you to find the area of B. Oh yeah, B. Sorry, Actually, we don't even need to find D, right? So 5 units equals to 5 times 6. The answer is 30. Well done. So Ben, was this easy?
Yeah.
Good job. Okay, the rest of you, any questions? Raise your hand, anyone? No? Okay, now let's try one last question, okay? So students, this is also, I would not say that this is easy, Okay, this is not that easy. Not that easy. Junyi, can I ask you to volunteer for this, Junyi? So, Junyi, we already know that if there are two triangles that looks something like this, can I say that they have the same height? Yes or no?
Yeah.
Okay, let me draw the height for you. Okay, this is the two triangle, right? Okay, the height is 90 degrees. Agree, right?
Yeah.
Now, if they have the same height, that means the ratio of their base is the same as the ratio of their what?
Unit.
Their what? Area. Okay, that means if I tell you that, okay, if I tell you that this has an area of 20, okay, then I tell you that the base here is, for example, 2 unit, and the base here is 1 unit. So can you tell me what is the area here now?
20 divided by 2.
Very good. 10. Okay. Now, what if I change this? I change this to 4 unit here. Then can you tell me what is the area here now?
20 divided by 4.
Then what is the answer?
5.
Correct. Okay, well done. So now you understand this. Okay, so now let's look at the question. First, I would like you to look at the yellow triangle. Okay, when we look at this yellow triangle, the question already tells us that the area of BDE is 10 cm square. They also told us that AD and DC 6:5. And they also told us that point E is the midpoint. What is the meaning of midpoint?
The middle.
The middle. So if this is the middle, can I, then how many units and how many units should it be here? Can I say 2 unit and 1 unit? Is this going to be a midpoint?
No.
So are they going to be the same length here and the same length here? Yes or no?
Yes.
Okay. If they are the same length, I should give them the same units. Okay?
Yeah.
So I can just say 1 unit, 1 unit. Or if you want to do 2 unit, 2 unit, 3 unit, 3 units, up to you. As long as they are the same. So I'm going to say 1 unit and 1 unit. Do you agree that these two triangles, this triangle, yellow triangle, and the green triangle, they have the same height? Yes or no?
Yes.
If they have the same height, then this is 1 unit, this is 1 unit. What is the area here?
10 cm.
Correct. It must be the same. Well done. Now, this is the easy part. We are now going to do the difficult part. Are you ready?
Yeah.
Okay, good. First, we need to make sure that this is a yellow triangle. Can you tell me what is the area of the total yellow triangle?
20 cm.
20. Very good, 20. Then I'm going to make this the green triangle now. If you look at the yellow triangle and the green triangle, will you say that they have the same height?
No.
No. But what if I draw it a different way? Okay, what if I rotate the entire diagram? What if I drew it like that? Oh, sorry. What if I rotate the entire diagram and I put the point A, I put it here. Okay, point A is here. Point D. Point D is here. ADC. A, D, C. Okay, Then after that, I put point B. No, after C is E, right? Then after E is B, Okay, then now the yellow triangle is here now. This is 20 cm. You already told me it's 20, right?
Yeah.
Then this is the green triangle now. Can I say they have the same height?
Yes.
Very good. So if I want to draw the height, I can draw here 90 degrees. This can be the base. That's why at the start of this lesson, I asked everybody, does the base always need to be at the bottom?
No.
No need. The base can be anywhere. As long as the height is 90 degrees, then it will be correct. Okay, Jenny?
Okay.
So now we know that these have the same height. And we know that this is 6 unit, this is 5 unit. And you already told me that the yellow triangle is 20 cm square, right or not?
Yeah.
Now you tell me 5 unit equals to how many cm square?
20 cm square.
1 unit equals to?
20 divided by 5 equals 4.
Then the green triangle is how many unit?
6 times 4 equals 24.
And we solved it. Well done, Ginny. Any questions about this?
No.
All right. Students, how about the rest of you? Questions? Okay. The last question is a challenging question. It is optional. If you are able to do it, go ahead. If not, it's okay. I'm going to send you the solutions. So, students, well done today. I know it's not easy. Okay, you need to use your visualization skills, right? But please remember what we have learned. Butterfly concept, how to find area of a trapezium. We also learn same height. If they have the same height, that means the ratio of the area is same as the ratio of their base, right? So the solutions and the lesson recording is going to be emailed to your parents tomorrow morning. So please take a look, do your revision, try to do the homework, take picture of your homework and send WhatsApp back to me so that I can check it. Okay? Good job today, everyone. I'll see you next time. Bye. Bye, Abby, Kate, Jenny, Maximus, Nicholas, Talia. Bye.